The next part, this is your median. So this is just another way to measure a center. This is a little different. A median or mean used all your data points in the calculation. So median isn't exactly a calculation though. It's more of a position. So the median is a number that splits the ordered data in half. So that half the values are less than that median and half are greater than it, or approximately. Sometimes your median happens to be in a weird place and you can't do halves. The procedure for computing a median differs depending on whether we have an even or an odd number of observations. If you have an odd number of observations, like let's say these are my observations, and these should be ordered from smallest to largest. So if this is ordered, smallest to largest, what we see is that this data point right here, that would be the median because about half my data is below and half my is above. We got 3 points below it, 3 points above it. If your median is, or sorry, if your data is has an even size to it, then we still do the same thing. Everything's ordered from smallest to largest. It's just that we take the two data points in the middle and we do an average, or basically a mean. But in that case, your mean is going to be right here, exactly splitting that data into two halves. Always remember, you need to order your data from smallest to largest. Accidentally left a solution on here, so let me get rid of that for a second. It was the wrong color. There we go. So during a semester, you take these exams here, or took exams and you got these grades here. So we already looked at this data. So last time we looked at the mean, it was an 81.2. Something close to that. Now we're going to actually look for the median. The first thing we're going to do is order data. From smallest to largest. We call that ascending order. I'm going to arrange my data in ascending order. My smallest grade that I got here was at 68. That goes first. Then the next smallest was a 78. I'm just crossing them out so I don't accidentally use it again. Then we have an 83, an 85, and a 92. So we see that this value is exactly in the middle. So that one value in the middle, this means that my mean or median is 83. So half of my grades were less than 83, half of my grades half of the students' grades are less than 83, and half of them are greater than 83. So about half of the students' grades are less than 83. So we say about because 83 is in there. So it's hard to do half when you have 5 data points, right? And then we got about a half of the students' grades are greater than 83. One of the things we like about medians is they do give us this halfway point. So there's some ways that they make a little bit more sense than a mean will make sense than a mean does. A mean is kind of like trying to balance the data out. Like I said, like it's not a balance beam. You're trying to find your not your focus, but your or I thought the word for it, and I said it earlier. But you know what I mean, fulcrum. You're looking for like that fulcrum that balances that beam with those data points on it. Median, you're just trying to find a halfway mark. So this is not so much a calculation, it's telling you a position in your data. And actually later we are going to talk about positions. One of my positions is the median. Okay. So once again, I had neglected to get this removed. I thought I had. My solutions. 8 patients undergo a new surgical procedure for the number of days spent in recovery uh, okay, number of days spent in recovery for each is as follows. We want to find the median number of days in recovery. So once again, order in ascending order. So we're going to start with 12, 13. We got another 13. Then we got a 15. Then we got a 19, a 20, a 21, and a 27. So when you reorder it, I always advise you to count because we had 8 patients here. We should have 1, 2, 3, 4, 5, 6, 7, 8. We should have 8 after you order it. Because sometimes when you're reordering it, you miss a number and then you kind of get things a little messed up. So what we see here, we got 2 data points in the middle. So when it's an even number of data points like we have here, we don't have one number exactly in the center. We have 2. You see there's 3 below it, 3 below it. So what we do, we're just going to take those 2 numbers, add them together, and divide by 2. And we're going to get 17. So you should notice that the 17, it's 2 points above 15, 2 points below 19. So it should be like equal distance from each point. But that is going to be my median. So once again, it's going to split my data like this. So we see that half of the patients recover in less than 17 minutes and half of them recover in over 17 minutes. Or not minutes, I'm sorry, days. Let's see, that didn't sound right for a second. Half of patients recover in less than 17 days. Of course, on the other side, it may take you more than 17 days to recover that. As half of people also have that as a situation they maybe that they may see. So there's a lot of things that we do measure with medians because of that concept of it's telling you a halfway point. One of them is incomes and housing prices. So when we talk about like median incomes for families, that median income is a halfway point. So if the median income, say I think Texas last I checked was like 72,000 is the median income. That means half of families in Texas make less than $72,000 a year. Same thing with housing prices. If the median housing price is, let's say, we'll make something up, $250,000, that would mean that half of the houses out there are valued greater than or selling for greater than $2,000 or $250,000, and half of them are less than that. There's some data that we use this with because it just makes it a little clearer to understand the situation. So going back to the age of precedence again, using your samples of 5 and your samples of 8, I want you to go back and then use those 2 samples and just find the medians for those 2 samples that you took. Okay, so using the ones I have before, so my sample of 5, these are the ages, so I just order them from smallest to largest. And even if a value repeats, we just keep that repeating value. So if I reorder it, it goes 51, 57, 57, 60, and 64. So we see here, my median for this one is 57. If I do this data over here, my smallest is 49. Then I have that 51, 51, 51. Then no, oops, I have a smaller one. There was a 46 in there. So it's right at the end there. And then I have a 52, a 56, and a 57. I'm gonna make sure 1, 2, 3, 4, 5, 6, 7, 8. Got 8 of them. So in this case, these two in the center, that's going to be my median because it's an even value. So if I take that and divide by 2, that is going to be, let me see, 102 divided by 2, which is going to give me 51 again. Just something to notice here that both of our medians were pretty close to our means, because I believe the mean for this one, I think was like, I have it down here. What was it, 57.8? And this one was pretty close because we had 51.6. Just something to point out there. So a lot of times we have certain kinds of data, we usually find that the means and medians tend to be the same. Okay. So we can use, especially when you have really big data sets, we can actually use the TI-84 to find means and medians. So I'm going to put in that sample I had from that I took of the 8 presidents as an example. So that was 57, 49, 52, 51, 51, 51, 56, and 46. Okay, so if we have our TI-84, what you're going to do is, no, I think it was showing the 84 in here. Just let me make sure that was sharing correctly. Okay, we got it now. So we put those data points again. You gotta be really careful with this and getting your data to share correctly. Okay, so that got messed up. But yeah, so we had 57, 49, 52, 51, 51, 51, 56, 46. Okay, so right here on your calculator, you see stat, and it says list above it. So naturally, you might want to try going to list, but you don't. You go to stat, and then we see number 1 there. Up there a little bit. So you either just press number 1 or you press enter over that number 1 where it says edit, but you want to go to edit. It's going to bring up this list. So what you're going to do is you're going to type in each one of your data points and hit enter. So just keep doing that until you get it all in there. And I've just so far had somebody ask me how many data points I can get in here. I'm not completely sure because I don't think I've ever hit a limit on here. I'm sure there is one. But there's all my data points. So that's my whole list of data in here. This can keep you from having to do like really, really big calculations with really, really big data sets just entered in here. So after you do that, we're going to go back to stat again. And you move over one, so you can see these keys move you. So we get to edit, we move over to calculate, and it says 1 var stat. This is 1 variable statistics. You're going to click on 1 var stats, make sure it's list 1. We don't have a frequency list. We just have calculate. So like I said, 1 variable statistics. And what you see here is it's going to tell you right here, what's my mean? Oh, I was rounding it last time, but it is 51.625. And your median, you will also find it's not going to be labeled the way you think it would be necessarily, because we haven't quite got to all that data yet. But if I scroll down, oh, it does say median. Sometimes they say a Q2 in there. Ours says median. But you do see Q2, that's what's referring to. But then my median is that 51. We're going to learn what the rest of the stuff is because this is standard deviation. These are quartiles. You get a minimum, you get a maximum value. So it tells you a lot of information. It's going to give you your sample size of 8. So keep in mind where this one var is because we will bring it up again. But if we had a big data set and we want to calculate a mean or a mean, median, standard deviations, a few other things that we can calculate with this, we go to that one var stats after we enter our data in the list. So once you try this on your own, so one of the easiest data sets I can actually find out there is on Bigfoot. So this is the number of Bigfoot sightings in a sample of 10 states. So use the 84 to enter in that data. So like I said, this is just sort of kind of randomly chose 10 states and the number of Bigfoot sightings that they've had over time. But enter that in and just try to find your mean and your median. Okay, so if I went into my edit list again, and we have all that old data in there, we don't want it, go up, so highlight list, clear, hit enter, and it'll clear that entire list for you. So now we can put in those Bigfoot. So we got one state had 19, 259 in another state, 225 in another, 59 in one more state. I got these all in there right. 463, 74, 5, 98, 729, and 6. Enter. Okay, we got it all in there. So we hit stat again, or have our list. We go over to calculate one var statistic. So you don't always have to hit enter. I can hit 1 because it's telling me 1 there. Like if I want to do linear regressions, I just push 8 and it does linear regressions. If I push 1, it takes me right to one var stats. I'm using list 1. So if we did have to use another list, say like I put everything in list 2, you would just hit second, and right there you see L2. That second, anything that's in the blue will be brought up by hitting that second button first. Second L2 will give me L2. Second 1 gives me L1. Right, so I'm going to hover over and delete them because I don't need 2 lists in there. I just need L1. I'm going to calculate. And what we see right here is that on average, the mean number of Bigfoot sightings seems to be in a state 192.8. Not sure how accurate that is, but and then the median, as you see, that's going to be really different now. My median, not even close. My median is 81.5. So half of states have 81.5 or less sightings of Bigfoot in the state. And then half of states have sightings over 81.5. So like I said, with that precedent data, our means and our medians were very close to each other. Here with the Bigfoot data, our means and medians are very far from each other. And that is because this is comparison of having kind of 2 different data sets. If your data is more symmetric or that bell-shaped thing or data, then you would find your mean and medians would be closer. If it's skewed, then you get data like this, where your means and medians are not close to each other. So what we have here is Bigfoot data. It tends to be really skewed.